in a larger system, more residential system, instead of having a built-in charge controller, a wind turbine would go from the actual generator inside the head to an external charge controller. This is a unit made by Outback for 80 amp charge control. Very rugged, very tough, made in America, made up in Washington State. This is a standard among the off-grid systems. It's basically like saying you bought the most bulletproof piece of equipment you could ever buy is with one of the Outback charge controllers. This really keeps your battery alive, turns it into something usable. This is an Outback inverter system. This particular model is made for farmers, rural residences, where you can have grid power most of the time with a battery backup system. It is not a light piece of equipment. Here we have the hookups for the AC input, AC output, chassis grounds, battery system, battery status, temperature, hubs. It also has a data port, so you can get wirelessly hooked up to your system to see how well your batteries are doing, how well your wind turbine's running. This particular model allows you to charge your batteries when the grid power is on, and it automatically switches when the grid power goes away to feed off the battery, so your house still has power. It will disconnect you from the grid itself during that time, so your lineman can go work on the line safely and try to get your grid power back into your system. These two systems work in conjunction, the charge controller and this battery backup inverter, which is real nice. They all plug in through the red and the black hots here. This again is one of the toughest systems you could ever buy. Farmers particularly like this. And when I mean farmers that get a little bit worse than we do here in the Midwest. Guys in Montana, guys in Canada use these systems because they can deal with the extreme cold and the extreme harsh conditions, which is why it's built like a tank. Okay, here we have the Outback charge controller and the Outback battery backup grid-tied inverter. Now I'm going to show how we go from the charge controller to the inverter and how the inverter itself would plug into the home. Here on Outback system, we remove one of the plates. Internally here we have renewable energy positive, negative, and battery positive and negative. The wind turbine would plug into the renewable energy input, and then a battery output would go from the battery output to these two positive negative terminals on the inverter. From the inverter here, positive negative, we would also plug our batteries into this two central hubs here. So both the charge controller and the batteries both plug into these here. Now, that's great. We've got power to the batteries. Now, how to get power from the batteries, convert it from DC electricity to AC electricity, happens internal, and then how to get the AC electricity out into your residence. So this is a covered plate here sort of explaining AC hot power out, AC neutral out, chassis ground for the output, chassis ground for the input, AC neutral in, AC hot in. So as I remove this, you'll be able to see this looks nothing more than what a typical junction box in a house would look. So with our AC hot out, when we're going to the house, we would pull lines, standard lines, off of here. Our chassis grounds would come off of here, and our AC in would come off of here. The AC in on this unit allows you to charge the batteries while you have grid power. And then when the grid power goes out, it allows you to run off those batteries in the same way. So this unit can actually convert from AC to DC and then from DC back to AC without fault or fail. And again, with this system, it's so robust. We use these in some of the harshest places on the planet. Around the Midwest, we know that we can have negative 30-degree weather. 6 months later, we can have 110-degree weather with 100% humidity. These systems are made to stand up to that sort of abuse. We do have 2 data port plugins here, which are really nice: a battery temperature data port and a information systems data port. The data port allows me to plug into a wireless remote system and kick it up on my laptop. So if you're out on the combine and you want to see how much power you're getting for the day, with the satellite systems on most combines nowadays, you can plug right up into the internet and see how your house is doing. If you're taking a vacation in Florida for a while, you can get online and see how your house is doing for power production. Very nice feature of this system. And then all of your LED lights to tell you physically while you're standing there how things are running.